G'day Year 7s, and I hope you're having a lovely time on your holidays, resting up big time, and enjoying your time off for one term to go. Can't believe the year is just about over already and you're moving into year 8 in, a bit over a term and Christmas holidays. Anyway, we've got a bit of work to do yet though, so let's get through this stuff. So here we are looking at reflections and rotations. So reflections and rotations, you're going to be using a grid or Cartesian plane that we have spoken about in our last unit, I think it was. Okay, so the grid paper here, or the grid that you can see here, and then using shapes, you're going to reflect the shape on a mirror line, and the mirror line could be anywhere. So in this case, it's mirror line. It can be used as the x-axis, y-axis, here can be used as a mirror line. The x-axis could be used as a mirror line. The mirror line could also go through the diagonally this way through there as well to create a mirror line. Alright, and reflections are drawn on that mirror line. So what the shape would look like if you put a mirror along that line and looked into the mirror. So just so we put a mirror along here and looked that way into the mirror, what the shape would look like on the other side on that reflection in the mirror. Okay, so reflection and rotation are two types of transformation. So here we are talking about transformations, and I will put that up here in brackets. Okay, and there is another one called translations, which we'll look at in the next video. Alright, so transformations. Now this video might be a little bit longer. That's really poorly spelt, but anyway. Just because we've got a bit of mucking around with one of the drawings what to do. But anyway, alright. That involve a change in position of the points of an object. So each of these points of this particular shape, in this case a triangle, are going to be transformed to another place on this grid. Okay, and depending on whether it's reflection or rotation or a translation is going to obviously depend on where those points end up, and then you redraw the shape. Alright, so it's simple as that. So when you do reflections, rotations and translations, it's basically you're going to move each of the vertices, each of the points of the shape, whether it be a square, a triangle, a pentagon, doesn't matter what it is, you're basically transforming or moving each of the points of the shape. Alright, so if a shape is reflected in a mirror line or rotated about a point, the size of the shape is unchanged. So with reflection or rotation or translation, the size of the shape doesn't change. The size remains the same at all times. So if you ever do one of these and the shape looks bigger or smaller, chances are you've made a bit of a mistake, because it is, it shouldn't change the size at all. Alright. So if we're going to redraw this shape using this mirror line on line A, for example, okay, so this dot here is not going to change. It is right on the mirror line, so that's not going to change. But this dot will. So this dot is going to be 1, 2, 3 spots, 3 points, this side of the mirror line. Okay, so 1, 2, 3. So, oops, don't want that. I need to try and draw a dot there. All right, so that dot is now here, and same with this dot. This dot is also 1, 2, 3 places, but on the other side of our mirror line. And then, I might use my line tool here, we can very easily redraw our shape. Okay? Normally, yes, you'd use a ruler to do that, and you need to make sure you use rulers. Now, if we're going to use the mirror line, the x-axis is the mirror line. Same thing, okay? So here's our mirror line. So this dot has to be exactly the same distance from the mirror, but on the other side. So this dot here is here. Draw a dot. Oop, that's why it's not drawing. I've got to change it back. There we go. This one, again, 1 unit, but this side, and this one, 1, 2, 3 units. 1, 2, 3 units. Okay, he's going to be there. And again, we get our ruler and our pencil and we redraw the shape. Again, sorry, that's not very straight, but yeah, and that'll be the mirror image on mirror line B. Okay, so that's what a reflection is. Rotation is a little bit different. We'll get to rotation shortly. Alright, some of the key ideas. So reflections and rotations are isometric transformations, and if we go back to these notes, isometric meaning, so transformations, reflection, rotation are said to be isometric because the shape of the size of the shape doesn't change. So that is why they are called isometric. Change my pen again. That give an image of an object or shape without changing its shape and size. Okay, so isometric means that the shape and size does not actually change. Its location changes, but its shape and size doesn't. The image of point A is denoted A dash. So for example, and let's go back here, just say if this point was point A, then this point is going to be, oops, A with a dash. If this one was a B, this point is going to be B dash. And if this was point C, this one's going to be C dash. Okay, so that's how you label the points, and as you can see in this example here, A and A dash, B and B dash, F and F dash, and so on. Okay, so each image point has that little dash associated with it. A reflection involves a mirror line, as shown in the diagram opposite. I've just gone through that. A rotation involves, okay, so rotation is a bit different. Okay, involves a center point of rotation. All right, so our center point of rotation, and normally I assume in this exercise your center point is going to be right in the origin at 0, 0. That'll be your point of rotation at all times. But a point of rotation could be another point. So I could say, okay, at this point at 2, -2, for example, that's going to be our point of rotation, and this shape has to rotate around that particular point. That's probably a little bit more advanced. So I'm pretty sure that it'll be all rotations will happen around the origin point. Okay, and an angle of rotation will also be given. All right, so for example in this image, this shape has been rotated around the center, around this point C, 90 degrees. Okay, so each point has been rotated, 90 degrees around this center point. Okay, so a pair of compasses can be used to draw each circle to help find the position of image points, and I might also suggest using a protractor, and I'll show you how to do that when we get to the examples. Okay, so here's our first examples. Hopefully all that makes sense. So a reflection is a mirror line. A rotation involves rotating the shape either clockwise or anti-clockwise. Can be either way. In this case, this has been rotated clockwise. This shape here, it's your original shape. Here's your image, rotated clockwise around point C, 90 degrees. Okay, so it can be clockwise or anti-clockwise. Okay, let's get to the example. So draw the reflected image of this shape and give the coordinates of A dash, B dash, C dash, and D dash. The y-axis is our mirror line. So our mirror line is here. This is our mirror line through here. So we've got to make sure each of our points, A, B, C, and D, are reflected on that mirror line. So if we had a mirror there, what would the shape look like in our mirror if we looked through it? So our point A here has got to be 1 unit to the left, so it's got to be 1 unit to the right. So there's A. B, same, 1 unit to the left, so it's going to be 1 unit to the right. C is how many units? 1, 2, 3. So 1, 2, 3. There's my C. I'll mark these. There's A dash. Dash doesn't want to work very well. B dash. C dash. And D, we are 1, 2, 3 spots. 1, 2, 3 spots. And there's my D dash. And then we just redraw the shape. So there. And you'd use a ruler. I should be using my line tool up here, but anyway, so there, that's it. That's all you got to do. It's really, really simple. Not hard to do at all. Make sure you label each of the points of the image as A dash, B dash, C dash, and D dash. Yeah, and it should look like a mirror image, basically. Okay, so that's a reflection, rotation. Okay, draw the image of this shape and give the coordinates of A dash, B dash, D dash after carrying out the following rotation. So a 90-degree anti-clockwise about C. So here's C, so it's around our origin. Now what I'm going to suggest that you do is, it can be a little bit tricky to get the whole hang of it. Some people can really visualize where that shape goes and what it looks like. If that works for you, that's fine. But I'm going to give you a technique which I'd rather you use, because it is a technique you're going to have to use down the track in year 8 or year 9 if you have to rotate by a point, if you're given a Cartesian plane and the point's down here, for example. Okay, so you really probably need to understand this method anyway. Okay, so to do this method, first thing I do is rule lines from my point of rotation, so it's about C. And I draw a line that goes through each of the points. So I'm going to go through a line through the point D, and I'm also going to do a line going through point A and B, even though it is just through the x-axis. I'm still going to draw that line and extend it at this point. Okay, Now I'm going to rotate it 90 degrees anti-clockwise. So anti-clockwise I'm rotating that way. Okay, I'll change back to that. So I'm going to rotate anti-clockwise that way. So now I'm going to use my protractor. There it is. Alright, now I'm going to rotate each of these points 90 degrees. So I'm going to move my protractor, I'm going to move my points A and B because they lie on the same line. So I'm going to put my protractor there, and this makes it nice and easy because my 90 degrees is obviously from 0 here, reading all the way to 90 degrees, it's my y-axis. Okay, so I'm just going to draw this line anyway. So from here, that line being 90 degrees goes through my y-axis. Okay, I'm just going to remove that for a minute. So these 2 points have to be exactly the same distance from my centre point. So point A, if I rotate it 90 degrees now, and as it says back here, I could also, actually it might be here, I'll have to go back a bit. Translation, sorry, bear with me, reflection rotation. Down here, okay. So if you have a look here, they've actually used a compass, a pair of compasses, to draw circles around so you have a bit of an idea of which line that they are going to remain on. Okay. See the point A here being rotated is going to be on that outside line. This point's going to be on the inside line. Point B is going to be on the outside line as well. So you can use them to help you as well. But I find this way is just as effective. Anyway, so points A and B both have to rotate 90 degrees. And it's got to be the same distance from my point of rotation at C here. So this point here at point A has got to be, and I'll better change that, in here. Oop. Okay, so there's my point A. It's a bit difficult to draw. Okay, so point A there, my point B has got to be 2 units away from my point of origin. So there's my point B. I might just draw an X for both of those points. So there's A and there's B. Now my D, again I'm going to use my protractor. Make sure that is right on the spot, which is there. I'm going to actually move my protractor now, so this 0, the 0 here is lying along this line. Okay, so I just need to move it until it's along that line. Get my pencil and I'll do a mark. So now I'm going to do 90 degrees from this line. So we start at 0 there, around to 10, 20, 30, 40, up to 90 here. So I'm going to draw, if it'll let me, from there. It's not completely accurate. Okay, 90 degrees. Now I'm going to get rid of my protractor at the minute. So this line and this line form a 90 degree angle, a right angle, and this point has to be the same distance away. So if I rotate it, it's going to rotate through and it's going to end up landing there, isn't it? Okay, at this point here. Okay, then I can use my line tool and redraw. Oops, that hasn't come out very well. And redraw my shape. Okay, so that would be my shape in there, rotated 90 degrees anti-clockwise. Alright, so I find it's probably a good method to get the hang of and get used to, because like I said, down the track you'll be given a point of origin and be given not just a nice easy 90 degree rotation, it might be like 115 degree rotation. And that's the method you have to use to be able to do that. So I recommend maybe getting used to this method already. Alright, the next one is 180 degrees about point C. So it doesn't matter 180 degrees anti-clockwise or clockwise, doesn't matter which way we go. I keep using that wrong tool. Whichever way you go is going to end up in exactly the same spot. Okay, so now I could use exactly the same method, but I just know that 180 degrees. So if I extended this line through here, where am I going through? Going through there. Okay, oh geez, that's not very straight at all. Anyway, if it was a straight line, you'd find that this point being 180 degrees, hang on, I'm going to redraw that line because that's really ordinary. Let's have another crack. I'm going to go from there. That one's looking a bit better, hopefully. Looking a bit straighter. So this point being 180 degrees, no matter which way you go, it's always going to end back up at this point, 180 degrees. Okay, These guys, again, if we extend the line out this way and we rotate them 180 degrees, doesn't matter which way we rotate them, this point is going to end up there, this point is going to end up here, and then we have, I should change the colour, shouldn't I? Might help. Go to a red, see if that works. There, there, and there. Okay, so our shape gets rotated 180 degrees. Alright, and I might just check to make sure that one looks good. Down, 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 down. Okay, there's that first example I did. Whoop, you can stop, thank you. Down a bit further, down a bit further. Whoop, whoop, whoop. Hey, stop. Dear oh dear, don't know what's going on. Let's go back. Sorry. Alright, so here's our two rotations. I don't know what was going on there. So there's that one there, which is the same as that one. And then this one here, which is the same as this one. Okay, so 180 degrees is pretty easy. Just extend your lines and draw them on opposite sides. Okay, almost like a reflection. 90 degrees, like I said, it's best if, yeah, get used to using the protractors. Hopefully that made sense. I think sort of get the feeling that was a little bit clumsy working through that one. But hopefully that makes a bit of sense. Again, practice makes perfect. You've got to get in and practice these guys. By all means, get on the hot maths and print out some of those hot sheets and have a practice at some of them. That'll help you. Otherwise, yeah, hopefully you're ready to rock and roll in class. All right. Thanks, guys. We'll see you on the next tutorial. Bye-bye.